Hey everyone, how's it going? Welcome to another stream. Today we're going to be doing some interesting things. Mainly, it's something that's been on my to-do list. We have a simple kind of SDXL based server that's running in one of our cloud servers, and it's there mainly for our own agents to use, and like maybe somebody will ask the chatbot every once in a while. But recently it's been getting more kind of accesses as people are using it. So we kind of need to scale it out. It's essentially started from the sample code. And I intend to keep it that way, right? Like I want to make it be essentially, not something heavy or complicated, but taking the normal Hugging Face code to start SDXL, and then scale it out to multiple worker machines, right? So that's what I would like to do today. So here I have a simple server. It's essentially a new project. We're going to start from scratch here. And I'm thinking of doing it in Python. I kind of was thinking about what language I should do it with. But kind of in the interest of keeping it just simple, because it's not going to be something super important or anything, but something to kind of see. Just wanted to have something that's simple for creating images. So that's the plan. Just going to do something simple from scratch on the screen or on the stream, since I thought it would be good to do. Essentially, the problem is that there's only one server right now, and it has one GPU, an L40 or an L4, and it takes like 5 seconds or so to process an image. And when a lot of people come and try to generate images at the same time, the requests do get kind of queued up, but it then takes forever for the response to come back, and there's timeouts. So like after a minute or 5 minutes, the request times out, but the request is still like being processed. So in general, there's nothing, I don't think there's anything we're going to do about canceling requests right now. That would be something I'll do for later. But what I want to do right now is just make it so that we can start like 8 GPU servers and process 8 more things at the same time, and kind of do that in a load balanced way. So my idea is we'll start with, well, it's not really the idea. In ExpressAI, we have what's called like the standard architecture, where we have a front end and a RabbitMQ server, and then the workers in Python. So the current code is a Flask server essentially. So we're gonna kind of replace that, or we're gonna keep that Flask server, but instead of just that Flask server, we're also gonna have workers that are behind that Flask server doing the processing. So let's kind of get into that. I'll be kind of doing things from scratch here. Nothing too interesting. This is on Google Cloud, so I'll kind of take the code that we have already, which is essentially sample code, and I'll start that as the worker. So this server will be the main thing, and what I'll do is I'll create a new file called worker, and that will do that. I think I want to pip install the what was the name of the library? RabbitMQ. It wasn't Photo. It was Pika. That's what it was. So I'll pip install Pika here. And I think we'll create a new file. Yeah. So the requirements txt, say that we want Pika 1.3.2, Flask 3.0.0, Flask, we want Flask cores. Let me install that one. So pip install Flask. Okay, so we do have Flask 3.0.0 and then pip install Flask cores, which is 4.0.0. Okay, now the worker, it's probably not a good idea to have them both on the same project, right? Like, but dealing with multiple projects in IntelliJ is kind of annoying. So what I'll do is I'll call this requirements server, and then I'll make a requirements worker. Yeah, something like that. So the worker will not need Flask or cores. It's just going to use Pika. And then we also need the kind of imagine source code that we have. So let me look at those requirements in there. So we're going to need transformers. And transformers should get us everything we need from Hugging Face. I think we also need diffusers. Let me check. So if I pip install transformers here, yeah, Hugging Face Hug is there, tokenizers is there. UTDM, safe tensors, pretty much all I need. Okay, so transformers is 4.35.2, which is the latest. I'll stick with that. And then we also want diffusers. Zero dot 23.1. Was there anything else we needed? Freeze. Let's see, do we have accelerate? We do not. We probably want accelerate. And if you notice in the pip freeze, I was kind of considering whether I should do this with Google PubSub because this is hosted on Google Cloud. And I might still do that, but I kind of do want something that's not like cloud specific, because we do have our on-prem servers, and yeah, everything we do, we just want to have the ability to not be forced to use, not be forced to use, like Google Cloud, even though we're perfectly happy with it for the most part. Accelerate 0.24.1, that's a new one. That also picked up Torch for us. That one might be a little interesting. Torch is always going to be kind of interesting when it comes to that. I think because we're using SDXL, we also need to install the invisible watermark. invisible watermark. So let's get the latest version of that in here, and that gets us OpenCV Python. I think that's mostly everything. Okay, so I think that's everything that the worker will need. So let me just kind of look at that. Yeah, I think that's everything. So anyway, so let's get started with this worker. So essentially what we'll need is from diffusers, import diffusion pipeline. We'll need torch and UUID, because we're going to be doing that. Now, even though I said we don't want to use Google Cloud, we do need to save these files in a place that is like available. So essentially, because we have multiple servers here, when we do create the image, we need to upload them somewhere. So I do think we'll probably do that. So I have installed that already. So from Google Cloud import storage, yeah. And we won't need PubSub, but we will need Pika. I always forget the name. It's a weird name. Anyway, let's get, so the storage client is there, and our bucket name is going to be YouTube storage 1. There we go. Well, YouTube で。じゃあ消しといて。じゃあその動画。One second. Sorry about that. It's 10:30, but kids are still not asleep, as you can imagine. Happens quite often. Anyway, so yeah, image storage 1 is a bucket that I've created. I'm pretty sure. So we'll be using that. And how the authentication is going to happen is going to be something we'll look at later. But anyway, let's see. So we want this worker to just like load all the models and stuff when it starts. So we'll just kind of like do that anyway. So like the base diffuser with diffusion pipeline dot pre-trained, and we're just going to use the English one, but I want to experiment with the Japanese one here too. So let me just copy from diffusion Excel base. I guess I'll have to type it. Ability AI stable diffusion Excel base 1.0, and the torch D type should be float 16. The variant should be variant. Should be FP16. And then use safe tensors should be true. So let's make that be a little bit better in terms of our horizontal space. Now, base to CUDA is something that I do want to test this on this machine, so we'll comment that out, I think. Or maybe I could do if Copilot help me out here. I'm pretty sure I can do like torch.CUDA is available. Yeah, so if torch.CUDA is available, then we'll do that. Okay, and then we have a refiner, which is from pre-trained. This is Stability SDXL refiner, right? Stable diffusion XL refiner 1.0. We want our text encoder 2 is equal to base.text encoder 2. VAE is equal to base.VAE. The torch D type is that. Use safe tensor is true and variant is FP16. Again, if torch.CUDA is available, then we'll take that refiner to CUDA as well. We'll do, so one of the things is I don't want to have too many like parameters in this particular one. So we'll just do like some hard code, some like values here, I think. And steps is 40, and then the high noise fraction 0.8, pretty much good enough. Okay, so now we need to do the Pika stuff. So let me see. Connect to RabbitMQ and listen. More messages. Create a blocking connection, create a channel. We do our imagine queue, right? And then we want to, what do we want to do? We want to do connection dot add callback thread safe. No, we want to look at the find documentation because I always forget how to do this. So Pika consume messages. Okay, so you have your channel and then you can consume a message in a for loop. Oh, it's a generator. Do I like using a generator here? Have not used that before. I'm using the blocking connection to get message. So there's basic get. Yeah, that's how you do it. Yeah, this is mainly what I was thinking. You'd have an on message callback. You call start consuming, and then close when necessary. So I'm more familiar with that, so that's what I'm going to use, I think. So we have our callback, and for the callback, we want to receive the JSON. So let's also import JSON here. Let's scroll up. Okay. Yeah, we can do that kind of thing. So we have our body, then our, instead of image, we want a prompt from there. And the rest is kind of useless. So we'll have our prompt. We'll do image is equal to base, and then we pass prompt, we pass the num inference steps is n steps. There's also denoising. And this should be the high noise fraction. And the output type should be latent. Okay, then we take the images from that. And then we do image is equal to refiner. We put in the prompt. Image is that. And num inference steps is correct. Denoising is correct. Output type I don't think is required. And we want images 0. Okay, from there we make a GUID. Like so. I'll make a GUID path is equal to images, PNG, then image save, GUID path. So now we have a local image. And then we upload that from file name, exit, we acknowledge. And so do we want this to be a RPC style call, which we can do. It's a little heavy, right? Like, so essentially now that we're done, we have an image, we need to send that image back to the server. The other thing we can do is we can, just get that GUID from the server, so the server already knows what the URL will be for the message. It's a good question. What is the good way of doing that? Let's see. The RPC way does kind of make sense. So essentially, the RPC way is that the server creates a queue. So it creates the queue, then it sends the message and puts the name of that queue into the message. Then when the worker receives that message, you'll get the name of that queue, and when it's done, it should send the result onto that queue, and then the server will receive that result and then delete the queue, right, the response queue. The other way of doing that is to have, like a topic of, images when they're done, and then the server can see what GUIDs it has in flight right now, and then when there's a GUID done, then it will respond to the caller that it has completed the thing. That one's kind of nicer in the sense that even though now I'm using RabbitMQ, later on I might want to use Google PubSub because the thing is hosted on Google. So and Google kind of works better in that way. So even though RabbitMQ is totally capable of doing it in this RPC style, and we've used it before, I think I'll go with that topic thing. Okay, so we'll remove that, and then what we want to do is send message URL to his topic. So let's see if that works. So we have a stir here. Okay. I'm going to encode UTF-8. I think we do need to declare images, although the server will use it, so I think that's fine in general. Okay. Now the way this needs to work is that this GUID needs to come from the server. So we're going to have the prompt be body prompt, GUID come from that. We'll get rid of that. Upload from file name. Do that, and then we need to os.unlink the GUID path. Do that. I'm not sure what this X thing that I'm not sure where Copilot is getting that. Anyway, we do worker, imagine worker received R, then we get that. It's always good to know, to kind of have a log of things. And image worker, put image worker completed, or imagine. I called it imagine here. So completed, and we'll put the GUID. Job. GUID. There we go. I think that should work. I want to use single strings here. And here too, I think. Because everywhere else we're using single quotes. Okay, and then after this we'll print workers and 2 images. And then let's also put the public URL here. Okay, so in general, that should be our callback, and now we need to start consuming. We don't need to do anything there, and then we try, and we'll start consuming. Accept keyboard interrupt or any interrupt. And then we stop consuming and close. Cool. I think that should be everything in the worker. We don't need the UID. Okay. Now I need to do something about the storage client credentials. Is that a thing? Yeah, I don't think that's a thing. It should be credentials. And credentials is a credentials. Could define it in the environment too. And then we have our credentials. We can create one from question. Let me look at the Google Storage Python. I'll use example code, which I think will start with the whole permissions and stuff like that, because that's kind of pretty important. And it does not. Okay, let's go back here. Let's look at these. And they have a Google Cloud Storage for C++. That's unexpected. So we got Google Cloud Storage. We do that. Do that. Create bucket. We don't need to create the bucket. Upload objects from a file system. Okay, and we need the client libraries. Got the upload blob. And the authentication, I guess, is handled in this docs, right? And libraries. Python. We'll set up authentication. And local development environment. Service account is what we want. EDC file. So if we have the environment variable Google application credentials, the path of the JSON file, that's all we need. Okay, so got to do that. So we don't need to specify this here. Just have that. So let's create. So I think this will actually run, but if I run it, I'll have to download this mod, which I don't think I have. I think it was in cache. Cache. Hugging face, diffusers. Unfortunately, I only have Stable Diffusion v1. Anyway, so let's run this and then while that's downloading the entire internet, we will work on the server. Let's not have storage buckets get access to the Google Cloud Storage bucket. Great, so let's do that. Okay. Imagine storage 1. Let's get in there. Permissions. Egan's also expressing is folder admin. But I guess I'm a folder admin, but not a bucket admin. Bucket. Legacy bucket owner. Okay, so it's legacy, which is weird. Didn't seem like there was anything other than that, and that doesn't work. Okay, so let's try to grant access to myself, and then I need a role of storage. Let's not use that filter. We want, what is it? Cloud storage admin. At least for me. We'll have to figure out the thing. I'm only getting the bucket here. And I'm not sure what storage bucket gets is. Let's try that again. Okay. This, does it take a project? Should. Agent platform dev. Let's try that. Although I'm pretty sure I'm like in that project right now. Man, it's so annoying. So annoying. I'm a storage. Imagine storage 1. Well, let's use the G-Cloud API. What can we do with storage? So I can look at the buckets. We can list them. So we have a few buckets. This is the bucket storage I want. What else can I do with the buckets? Can't really do much with that. Okay, so let's say I do storage copy, right? And there's a source and a destination. So the source, and let's just do the worker.py, right? The destination would be Google Storage : imagine storage 1 /images test. Works fine. Fun. Thanks, Google. So great. Amazing. And if I look at the images, there is a test by in there. Okay. So let's now delete little RM that thing. And try the worker again. Maybe there's something special. StartToolAPS.com. Projects, projection noise, false, forbidden. What in the world could be preventing me from accessing this? Let's look at the fine documentation. Okay, so we should import storage, client, create bucket. Don't need to create a bucket. We already have it. We just need to, do stuff. Why do you have to be like this? Import from Google Cloud, import storage dot client. We specify a project, which should be the default project in this thing. And if I go get bucket, and work. What if I get a different bucket? What other buckets do I have here? Could I possibly get? Ooh, do I have to specify a region? I might have to specify a region. Region is the region for image storage was Europe West 1. Yeah, Europe West 4. Where do you specify the region? Do you need to specify the region? It doesn't say you need to specify the region. Is this stuff more useful in the other languages that Google actually uses? Let me see if I can list a bucket. Okay, got the client libraries, go to Python, list buckets. Okay, how about that? Let's list these things. I list the buckets and then get that one. I have a bucket. And what can I do with that? Can I list blobs? Expand the iterator? Yes, I can. What in the world is up with this error? Why can I not get that bucket? But I can list it. I have to do something stupid like list buckets. So if I have my buckets, and what is that have? Does it have a name? Yeah. How does filter work? Function and then iter. This is dumb, and I don't understand why I would need that. Yeah, let's let that download. I need to, this is going to return a list. I need to get the first one from there, so we're not going to actually consume anything. We also don't have RabbitMQ running, so let's kind of do that. So I should have RabbitMQ in my brew services. Yeah, so I should be able to start RabbitMQ to have that running. Okay, and now we're just going to wait for that to download. Okay, so while that's downloading, let's go on to the server, shall we? Okay, so for the server, we'll do the simple Flask stuff. We don't want send file, and we want cores. Ooh, actually, that reminds me of something. So in the worker, also want to import GC. So stuff kind of just barely runs in the memory. So in the callback, after we have done that, we want to do a couple of things. So we want to del the image, because we don't need it anymore. We're going to do a GC collect. And a torch.cuda empty cache. Yeah, so let's do that before I forget. Okay, so now with those imports, we also need Pika. So import Pika. And I think that's mostly what we want to do there. And we do app flask dance, cores it. We have app root. Let's give ourselves some kind of index. I'm going to use single strings since I'm using them everywhere else. Okay. I want to do the post. So we post to Imagine. We take the prompt, which comes from the JSON. And then we want to connect every time at the channel. What was this called? The queue was called, yeah, Imagine queue, so it's pretty smart. We'll publish. Body is JSON.dumps, right? And then the GUID will be UUID for a string that. So we need to import that. Coded as UTF-8. And yeah, returning success and then having them pull whatever would be the good thing. But in particular, we need this to be simple because it's being used by agents and stuff. So this needs to block. So wait until UU is found in images topic. So let's get rid of this. Plus GUID. Now let's get that prompt. Let's create a UID. Let me stir that up here. We only care about the string value of that anyway. Okay, and then okay, so this is a topic, not necessarily a queue. So until, let me see if I can get it to that better. So wait until the GUID appears on the images topic till this particular GUID appears on the image topic. That would be cool. Consume images. It's using that generator, which I'm not a fan of, but it makes sense in this case, right? Because we're in here. And this is going to be a thread. So it does kind of make sense for the blocking connection here. But now I'm kind of wondering, how does Pika deal with async? Let me do async Pika flash or flask. RPC client is not really what I want. But yeah, if we have RPC call, it doesn't use async. So if you have an async Oh, AIO Pika. Okay. Makes sense. So we'll pip install AIO Pika and see if we can do this with async. So let's add that to the server. AIO Pika is that. I'm not going to use that one. But version 931, is that correct? Yeah, 931. Interesting. So we can do this, and then we have an async main loop. We connect robustly to the server, and then with connection, we can declare our queue. Then we can have an async with to do that. Do we want to have a connection per server, or do we want to have a connection per thread? I'm guessing the simplest way of going about this will be connection per thread. Well, it's not a thread, it's a greenlight because we'd be using async, right? Yeah, we just async, and then we await, and then everything should be fine there. I want to make sure we install this. Do we not need that? I guess we don't need it. Okay. Okay, so if we do this for the server, we will want to, just do that async. So we'll do an async generate. And now we need to figure out how to do the async publish. So let's do, why are we using async IO? Either down there in the mains. Okay. That's cool. So let's do that. Include images, and we publish that. Okay, and then async this, was it? So if we want to get those, we want to, haven't used this one before, so kind of like in the dark here. But I think there was an async with queue iterator. Okay, so we want this queue, and then imagine queue. Wait a second. Let's create a channel, declare the queue. Then with the queue, we can do this stuff. How does publishing work? We have our channel. We publish the routing key being the queue that we want, right? Yeah. So when you publish, you don't really use the queue. This is just creating the queue if it doesn't exist, which I guess is okay. Okay, then we do need that queue now, so let's do the images queue is equal to await channel declare images, right? Don't auto delete, and then async with images queue iterator. And then async for message, we load that body, and then if the worker sends us URL, so having the URL is nice, having the GUID is also nice. There we go. So we'll look at that. Now, if body GUID has that GUID, then we acknowledge, and we can return our response. So do body URL. And then what we want to do is return a JSONify, after we act. We break. No, we return, so we don't need to back unresolved reference routine. I guess we don't need to act because we're reading it. It is a topic anyway, so I guess it doesn't matter. Goodness, lost words. Message body. Are we using message somewhere here? No, I don't think so. Yeah, it's some sort of coroutine. And we load that. I see. We want async with message process. That will acknowledge. And then we want body dot code UTF-8, because it should be UTF-8. It actually does loads. Yeah, you can load just from the bytes, like so. So for message in queue iter, yep. Async with message process, yep. And then message.body should be available. Okay. And if somehow we get here, we return. If we get here, something is wrong. I don't know what the 500 is. We want return that request 400. It's a tuple, right? So we would do JSONify with 500. Is that doable? What was this JSON up here? We did get response content time. I think that's JSONify, right? Yeah. So JSONify, we'll just say here something wrong. GUID prompt, I guess. Yeah, sure. Why not? There's something went wrong. We don't know what it is, but something like that should be good. Okay, let's see if we downloaded everything. Have we downloaded? We may have downloaded. Let's do that. Get the worker did I remember to do? Object is not scriptable. Was there first? I get the first of get first. Okay, so that matches name. So let's do that. That is the stupid way of doing it. Which I knew. I wanted to get the first body matches name without getting everything. Next, yeah, okay, that's what it was. First is next, so let's do that. Okay, we'll go to host 5.4. port was 5671. Or not. NVMe port is 5672. Or was it 15672? Something like that. It's been a while. Or 36. What ports is my MQ use? So we want the admin MQ admin port is management plugin, which I have enabled, and that thing is 15672. Did I not try that just now? Yeah, I know it's a bad password. Doesn't matter. Connections, channels, exchanges, and queues. We do have the 2 queues here. Now, this is a queue, and images is not supposed to be a queue. It's supposed to be a topic, so we got to do that. We got to the stop iteration. Fuck. Okay. Is doing it the stupid way the only way of doing this? If I spelled it wrong. Yeah. Let's do that. So that'll get us the first bucket. Make this buckets. There we go. We load those things. Now we're just waiting on the image queue. Now we can test this. Publish message manually with the payload GUID ABC123 prompt lion. No, that's an interesting prompt. Lion in a spacesuit. Loading in space. Publish. Layer norm kernel impl not implemented for half. I hate you, CUDA. My GPU totally supports 16-bit. What's your problem? Let me see if there's some sort of Stable Diffusion Mac. Sure. Well, I don't have an M1. Oh, that's annoying. Oh man, that's so annoying. We can publish it and do this stuff. It's just I want to test it locally, and it should work locally. We can do float 32 as the torch G type, but load the FP16 variant so that we don't have to download it again. That could be a thing. Nice to do this on my Mac. I can totally do it on my GPU machine. But I'd like to do it on my Mac. Which is kind of the sad thing. I mean, I could totally make a Hackintosh, but a Hackintosh is not so useful. I mean, for me, right, like not having NVIDIA drivers and things like that for deep learning things makes Mac not very useful for me, or makes a Hackintosh not very useful for me. And I do have a kind of like VM with things set up with experimental NVIDIA drivers, and it's kind of a mess. Can't show you, but because it's connected directly to the monitor. It's running on a 970, and which is not a great GPU, but there's like artifacts everywhere, and the only one that really works is like the 700 series. See that? Oh man, look at that Intel machine. Google those watts, 110. Okay, but anyway, it looks like it's working. Not sure if I'm going to wait for it to get to the end. So it will take about how long? Somewhere between 35 minutes. We can speed things up. Let's put num steps to be 2. Let's stop that because that's kind of useless. No wonder this PyTorch with metal, right? PyTorch metal GPU Intel Mac. Pretty sure that should work. Need to use an MPS device. Let's try that. Okay, so we do base. If that, then do base to MPS device. Same thing here. Just because it bothers me to have yellow, I'll just do that. I think 2 is going to look like crap. Let's do 10. We did not acknowledge the message, so it should come back. Let's see if that MPS works. Now the GPU on this thing is not the best, sadly. Like when doing Llama 2, kind of works faster on the CPU than on the GPU. Okay. I cannot use float 32. I do float 16. Pretty sure I can't do B float 16. 13 gigabytes. Half of that should barely fit. I'm not sure if I can generate an image though, but I should be able to load it at least. So let's look at the activity monitor just to see what's going on. Don't need you. Looks like the GPU is not doing much. Ran out of memory. Yeah. Let's see if that works in that. But it is a big model, and I only have 8 gigabytes of RAM on my GPU. So, you can already see not sure if you can see the weirdness happening here, but yeah, it's not ideal. So that looks like it is working. Let's change these to else ifs. That way you don't have to deal with, this if we're running on that. Okay, so we are using the GPU. I think it's not being very efficient because the model doesn't fit in the memory, so we're like kind of paging in system memory for it. But it's significantly faster, so we should be able to see a line in here somewhere. Significantly is like, it's like the weird thing with this GPU. It's in terms of the kind of raw performance I get from it in Torch, it is sometimes 2 times faster than the CPU, which is weird, right? Like the CPU, when it's working out on matrix multiplications and stuff, it can be quite surprisingly fast. Also chews through 120 watts, right? It's crazy. But yeah, like this 5500M is kind of like slower than I expected, given the stats of it, right? Like the stats that it should have. The 5500M T-flops, right? It's supposed to have like 9 teraflops. I don't know. I've never seen performance that goes, yeah, that's about on par with 9 teraflops of performance. I've never seen it. Okay, cool. So now we're refining. Hopefully that should work. Now let me put this back to the original before I forget, which was what? Should be 40. That's to 40. There we go. Now Pika may time out on me on this one. Or not, because I'm using this, so Pika won't time out on me. I don't think. We'll see. Okay, the finer step is done. Kind of curious to see what difference like 10 versus 40 steps makes. I've never tried it. It's times like this when the M3 is calling me. Damn. That would do it. Let's try that again, shall we? I kind of wish they made heat sinks for the laptop. You know, like there's like laptop fans, like stands with fans on it. Those are useless. What I really want is like an actual heat sink with the fins and everything. It just kind of sticks into your laptop. I think that would make it kind of run maybe a little bit cooler. Let me try shifting. Well, my laptop's running fine. It says it's 80, but let me try shifting the laptop a little bit. Give it a little more space. Doesn't help that it's also streaming video, right? Okay, so anyway, so that's looks like it's okay. Let's see how long this will take on the GPU with the 40 steps. I forgot that I made it 40 steps. Then here, let's do flask debug run server.py. Method not allowed should be a get request. There we go. And yeah, I should be able to curl some stuff. So if I curl not to our Imagine public cloud, but to localhost 5000. That should get to the server, and RabbitMQ should show there are 2 messages in the Imagine queue. Oh, everything looks like it's working great. First try. First try. I've been doing this for so long. So it's easy to get it first try when you've done it like the last 10 years. Cool. So that's more or less what I want. The route needs to be /API/v1. If I save this, I'll lose that thing, so I'm not going to save it for now. takes 6 minutes to make an image. Wow. Okay, I'm not going to wait. Save that. Delete that. Let's go to the worker. Bring that to 5 or something. Start the worker. Start the server. And let's prompt one other thing. What is something that we can there's something cool that we can do. Cyberpunk Kyoto Street. And this is API/v1, imagine. Okay, so we've posted that. We have that. No, please don't do that. So take a minute for each image. It's not so bad, but essentially, like this is the state, right? Like people, when they start hammering this service, you gotta wait a long time because the server and like we had the whole image generation pipeline kind of tied to the server. It was running inside of Flask, which is not ideal when something takes time. Even if you have a really powerful GPU like the L4, it was taking a significant amount of time. So by having this queue, I can start up more than one worker essentially, and then they can all work on jobs as they come in. Now the next step for this is to then you can leverage more stuff. You can like batch images as they're coming in, so you can like process the queue faster. It usually doesn't change too much when it comes to the GPU, as long as you have the GPU memory. So that's another thing that I'll probably tune in a later iteration of this code. But very, very normal stuff. Just being able to do multiple prompts at once is faster. So anyways, let's see how bad. That is. Oh, we already deleted the images, so to see them, we're gonna have to go to Google Cloud. We want 5 ETH and storage 5. Gotta refresh. Imagine storage 1. Images. Where is it uploading them? Because I don't see them. Yeah, that would be good if it were true. Okay, so that's another thing we need to do when it comes to the permissions. We don't want to prevent public access. We want to enable public access. This is a bucket that we want to be accessible. So in terms of permissions, is there this? All users should be able to cloud storage object viewer. Yes. Okay. Okay, cool. So now that is kind of working. And we should be able to look at the second one here too. Yeah, kind of cool. Kind of like the style actually. So maybe I should add that as a parameter. Okay, Kyoto Street. That's definitely not cyberpunk, but whatever. Cool. So let's put this back to 40, which looked pretty good, I think. And we're pretty much good, you know. We have a server, imagine, that is that respond. Bytes object has no attribute read. Okay, so that did not work. So body. I see. So even though this thing said union stir bytes, but it's a FP, so it's requiring a file of some sort. So if we do load S code UTF-8, that should be essentially the same thing. So that should have restarted the server. This is still running. Let's do, let's go back to the worker has not been restarted, so I think it's still going to do it in the faster way. I have a prompt that looked really nice for that cyberpunky Kyoto thing. So let's wait for that to do the thing. We can look at our queue. Our imagine queue has one message queued up, and that's good. The others were acknowledged and removed. And as it is processing it here, it shouldn't take too much longer. It is kind of nice that I'm able to use my AMD GPU for this thing. Okay, that's done. And worker uploaded the storage to that. We have our storage link. We can look at it. Cool. This is a good start to this is a good start to a cyberpunky type of thing, I think. Okay, cool. So I like where this is at. Don't need Pika anymore here. Worker wants to do 40. And that's pretty much it. Yeah, so let's now deploy this on the server, I think. I think we'll deploy this on the server. We need a couple things. These things can be hard-coded or not. We create a new systemd service definition. Probably makes the most sense. I know someone's going, what? You're not using Docker? Yeah, let's do imagine service. Ooh, there's a systemd plugin. I like this. Okay, so we have our service. What we want is the unit. Description will be starts the imagine service. After network is required, yes. Now the service type should be simple. Working directory should, let's make it var www imagine. User www data makes the most sense. We want to have some environment. So let's do that. Okay, so Google projects. On dev, then we also want another environment. Google application. It's a weird thing, but var imagine platform dev. Should be fine there. Should be fine. Now, the exec start. That's the interesting one. We want unicorn, I think. Let me see. I haven't. No. This is the worker. This is the worker, right? So what we want is our imagine VM in Python. Worker pi. Yeah, something like that should be fine. And this isn't exec start. This is just exec. If I'm not mistaken, we can do exec, right? Good question. I think we need to do exec start. Exec stop. It's just a pill. It's just a kill with the term. Restart on failure as always, I think is good. And in the install, we want a wanted by multi-user target. We also want RabbitMQ host environment, RabbitMQ port, RabbitMQ user, and password. So I'll set those correctly, or just make it so that I have a private server for those things. Wouldn't it be great if Google Pub Sub supported AMQP? That would be all sorts of fun. Okay. What else? Okay, right. The other thing is this, I think, should be a topic, or as in the images type is classic. I think that's not what we want. Before that, I'm going to have to look at RabbitMQ topic exchange. Okay, so when you have Pika and you want a topic, so do exchange declare topic basic public publish there in the routing key. I'm not sure why we want to declare a specific exchange. Somebody knows, let me know. But what we want here is we are doing queue declare. We don't want queue declare. We don't need exchange declare either. When we publish the exchange, we want the topic exchange. Then the routing key is the name of the queue. And then exclusive true. Exchange queue name. Finding key. Critical. Okay, they're doing like kind of some advanced stuff here. If we have a topic, we can have routing keys. Queue is bound with hash and receive all the messages fragments of the routing key, like a fan out. It has a star. Aren't used in bindings. exchange will behave like a direct. Okay, so that's where it gets a little complicated. So essentially, what you need to do, or what's kind of going on here, which is, one of the interesting things, the way that RabbitMQ works, your consumers have a queue, always, right? Like that's what they listen to. And what you kind of do is the publisher publishes to a topic, and the topic will copy those messages to all the queues, right? And how it chooses which queue to send it to kind of depends on this routing key. And I think so do we want to go for the topic or direct? Some previous tutorial talks about it. Okay, so if we do direct, it means that it will broadcast messages to all consumers. Fan out. What I kind of want here is a fan out. Use direct. Message goes to the queues whose binding key matches the routing key. Can you have multiple? Perfectly found multiple queues thing binding key. Yeah. So that's what we want. And then for subscribing, you make an anonymous queue, right? Like the queue isn't important. And then bind it to the exchange, which is the topic. Okay, more or less, this is how it should work, if I'm not mistaken. So, one is direct. I mean, we could make our own exchange. Although I'm only going to have a RabbitMQ for this thing. How many caret consumers are we talking? So in here, I'm going to be running 8, but the idea is that, yeah, like it would scale up. So the more and more people are using it and the more load there is on the system, I'd like it to auto scale. But of course, because they're GPUs we're talking about, can't auto scale forever. I'm going to run out of quota eventually. But yeah, it's small. It's not like super huge. It's mainly just a way to deal with the long kind of processing times. Okay, so let's look at the exchange declare. So let's create an exchange for this thing. Okay, so I do my queue declares. I'm going to call this images. Make that direct. The name direct is so weird. Okay, and then in channel publish, which I do here, so the exchange that I want is my images. The routing key is also images. Let me look at the fan out real quick. Then maybe fan out is what I want. Yeah, that's what I want. Okay, let's keep it simpler. We don't need extra features in this one. Type is fan out, right? We have our images, fan out. And if we publish to that exchange, we're good. So publish to images, routing key, not needed. Cool. Now for the server, we declare the queue. We have a queue iterator. What we want is to have the empty queue exclusive true called channel declare queue. And then we want to channel queue bind, which does not exist. Okay, AIO Pika queue bind. Somebody must have seen this. Routing. Oh, queue.bind. Okay. So we'll have our images queue bind, the exchange images, no routing key. Wait that. Okay, so we create an anonymous image queue that is connected to the images topic. And then everything else is the same. I think that should work. If the worker happens first. So we will probably also want to do this on the server as well. Declare exchange. We want images and the type is equal to fan out. And we must wait that. There we go. Take that to the image queue. Now I also think we need to double check with multiple workers. Okay, so let's close everything. Okay, so first let's start the server. Then let's start 2 workers. and say goodbye to my memory. But I should have enough, I think. Let's see. I can feel my mouse getting slower. Hopefully you guys don't hear anything out of the ordinary. Okay, load those pipeline components, please. Yeah, I can't wait for Intel's next chip that has the neural accelerator. Even though I'm probably not going to get it, because I'll probably be getting an M3 or M4, maybe an M4 that already has one. But you know, when you only have a CPU and a GPU, and you're using the GPU for graphics things, and you're trying to do AI things at the same time, it's kind of dumb. Okay, so let's see, how well does that work? If this is smart and it's using like N maps, then we're good. Those two things will share essentially the weights. You gotta wait for the second one. But man, the performance right now, it's weird because, you know, like the CPU isn't super kind of like loaded, but the GPU is, and my frame rates are tanking. Even though, I mean, it's not really loaded, it's more like a memory thing. I could remove metal performance shader. I'm not sure. It would be interesting. Can I tell metal performance shaders that I want to use the CPU instead? It's a good question. I should probably check that out. Okay, let's look at the RabbitMQ to see what is going on. MQ. Yeah, I think if I want to have multiple workers on Q with the way this works, I need to have the queues. Every consumer can just be on the same work queue, right? Should be fine. Yeah, they'll be round robin. Yeah, round robin is what we want here. And what I want to see in the RabbitMQ is that there are two consumers. There we go. Yeah, okay, so that's good. We can get my memory back a little bit. Okay, cool. Let's do the curl in. Yeah, it's going to take a while, but whatever. I kind of like, you know, I really like RabbitMQ. It's kind of like underrated. It gives you the, like, Kafka is what a lot of people will go with, right? Because they're like, oh, we need the performance. And yeah, if all you want is like an event stream and multiple things are kind of chilling on that stream and doing stuff, then yeah, probably that is what you want. But you know, there's so much more than just queues and topics, and RabbitMQ allows you to do that. You can have kind of entire actor systems where you don't need an actor framework. You just have a set of processes that are listening onto a RabbitMQ, and they can talk to each other, and messages can get routed and stuff. You can create pretty complex systems. It's super flexible, and I think that's something that doesn't exist anywhere else, or not to the same degree. I don't think. Like the JMS systems, they're also kind of like you got queues and you got topics, and that's it, right? But with RabbitMQ, you got a little bit more flexibility in there, so you can kind of create a topic where things kind of come in, and then you have different, actors, and their actor ID can have some sort of name. So when you send messages here, it goes to the right actor. But because you have that flexibility of using wildcards, you can actually kind of have the same message go to two things, and they can race each other for figuring out who, you can do stuff like that. It's kind of hard to do that kind of stuff with regular actor frameworks. So yeah, I think that people should use RabbitMQ more often. Kind of gives you, like, when you're using Erlang actors, and that's kind of like the name of the game, right? But if you don't want to use Erlang, you can just use RabbitMQ to be those actors for you, So anyway, so I've posted that, and I'm gonna wait for this to finish. While that processes, I think I'll look at what else I need to do here. We're good. Yeah, I think we're okay. Let me go to the compute engine, Google Cloud, and in Europe, I'm going to create a RabbitMQ instance. Let me look in real quick if there's a RabbitMQ in the marketplace. Yeah, never mind. I'm just going to make an Ubuntu server. Let's create a new VM in the same region, Netherlands. So yeah, you can kind of see what I'm doing. But let me my instances and IPs secret. West 4A, and I just want a general purpose low cost thing, I think. 5 gigs of RAM. How much is my RabbitMQ using right now? Monitor. Rabbit should be Beam. Process name Beam is currently using 72 megabytes. Go to a small. Should be fine. Let's change that boot disk. I think Debian is fine. Oh, I have ARM64. That's balance disk, let me do 64 gigs. We don't want to allow anything. Anything. I need an additional disk. Keep it on the default network. And the name will be, say, RabbitMQ. I think 2 GB of memory should be enough. That should be plenty. It's not a high throughput, it's going to be low throughput. Okay, now there's 2 minutes going on there. You kind of, yeah, I wish there was like more usage of this going on. Gotta find a what's it called? Like a low rank SDXL. That would be kind of cool. Oh, I mean, it would be kind of cool for running on my laptop, at least. It has an external IP. I didn't want it to have an external IP. But it's kind of fine. Just firewall it all. Okay, so we're in our RabbitMQ. Let's apt install RabbitMQ. Search for it. Pretty sure it's RabbitMQ. Yeah, Rabbit is the presentation tool, for which I do think I'm on the credits for. Very long time ago. Is there no RabbitMQ? Yeah, RabbitMQ, sir. There we go. So let's sudo apt install RabbitMQ server. So do that. Now my frame rate is completely tanked as the refiner is now running. Let's give that a second to run. Man, this is really taxing the GPU. One other thing I could see is how well it runs on the Intel graphics. That would actually be kind of cool. It's like I kind of wish I could force the Intel graphics to be used for the display so that I could use the AMD Radeon for the deep learning things. And it kind of works that way if you're not using an external display, but I am using an external display. So doing it the other way is possible, but usually is a bad idea. The Intel graphics are crap. Okay, so that's something I need to worry about, which is that if this takes too long, then that can cause things to stop. Let me check. So rabbit queue back timeout. Timeout by default 30 minutes. Really? No, 3 minutes. "30 minutes by default." Yeah. Well, I guess it's not the ACK, it's the fact that this callback. It's fine. It's like, let's put this to 1 or something like that, or just 2, so that we can get it going. But yeah, it's a good point. The callback is blocking the thread, and that is a problem. I wonder if Pika has a thing. Pika callback blocking the thread. No, that's not what I want. And the thing is, I know that Pika isn't thread safe, right? So like doing stuff is kind of annoying. Add callback thread safe. And from the connections thread, add callback thread safe. So that is add, hold on. Okay, so what I want is that my callback is on a different thread, which doesn't matter, or doesn't block, like RabbitMQ's or Pika's thread for the connection to the server. And block connection timeout. If the user dispatches basic publish in a non-publisher confirmation mode when it's in synchronous state, request a call to the given function as soon as possible in the context of this connection's thread. Blocked due to the broker running low on resources. Connection unblocked. So so the issue is, so I can start this callback, like the whole image generation, on a separate thread. Can totally do that. But then there's kind of like a problem, which is that I need to wait for that. And waiting on that thread is going to have the same kind of issue for this because it's kind of slow. So I need a way to kind of wait on a thread and then give RabbitMQ its chance to process keep the connection alive while I'm waiting. So I think what I want is like a Pika threaded callback example of some sort to kind of see what it is I need to do. I do know that if so after this, right, like I save and I upload and then I ACK and then I publish. So these I'd have to do with that thread safe kind of thing if I do it from inside of the thread. But then it's done with the callback, so it's going to ask for another thing, another job in the queue. That's not what I want. I want the things to only pull from the queue when they're ready. And that is a little like strangely missing. I mean, yeah, I guess you can just have a mutex and try to acquire it. I think that's the right way of doing it. For threading, we also want to make a mutex. Okay, now I want to create a new thread. Don't remember how to do it in Python. I can thread with a function, right? Yeah, target, that's what I mean. Okay, so what I can do is we have a def generate image with a prompt and a GUID. Okay, this I move into that thread. This goes out in here. And then I do and I can do thread join. There a timeout for join? Yes, which should be seconds. When the timeout argument is present, it should be a floating point number specifying the operation in seconds. So you have to call isAlive after join to know if it actually is done or not. Make sense? So while thread.isAlive, we join. Let's do 5 seconds, 1 second. Yeah, we don't need that mutex. We don't need that lock. So let's get rid of that lock. Just wait for it to join. Resecond. There's something I can do from here that's the channel process messages. That's not a thing, right? That would have been too easy. We have flow consuming. Okay. Let me see if there's some Pika long callbacks. How do you supposed to do this? Turn off heartbeats. Yeah, don't do that. That sounds stupid. Connection process data events. I see that channel connection. That is exactly what I want. Okay, cool. So with that, it will start this, do stuff. Now to test this properly, set the steps to 40. We do these things in that thread. In general, this stuff should all be thread safe. And we're only calling it from one thread anyway, although we are creating it. Gets to the end. Every second, we're going to process any data events. And then acknowledge. Yeah, we do need that. That public URL, though, is just generated. Or no, you need to return that. Is Python able to return stuff from threads after they're joined? Returns none. I can get a string from this. That would be all I need. But I don't think you can do that. Python thread return string. Other than setting it and passing it. Join returns null. Multiprocessing is not going to work. Thread pool executor. That's not so great because we just have a thread pool. And we only want to do, we're only doing one thing at a time. So having a thread pool for that, it's not ideal. Let's use a queue, I guess. We then pass in the queue. And that in here. And load from path. And then queue, put URL. And then from here, do queue.get. Import this twice. Public URL is equal to queue. Result queue.get. This needs to happen in that thread. And then I think we're done. Okay, so let's stop that. Let's do it with 40 and then wait 5 minutes. Server is running and happy. Post Tokyo Street, man in kimono, umbrella, umbrella, something like that. Let's make it something cool to look at, hopefully. See that, and we're going to get started. And hopefully, if this works, and that's mostly done, now we need to get these things into kind of environment variables that we can use, like the connection parameters for RabbitMQ. And that should be pretty much everything we need. Is there anything that's missing? I don't think so. And of course, on the L4s, they're not going to have this issue, but you know, it's the correct thing to do. You want to make sure the threading and the queue works correctly. Now if this fails and joins, the queue empty, queue.get will fail. And so I guess I do have to protect against the failure. Oh, maybe not. It will restart on failure. So yeah, just let it fail, I guess. Let it crash. It is the actor way. Cool. If anyone has any questions or anything like that, happy to answer it. For those just joining and wondering what in the world I'm doing, what I'm doing now is we have a kind of service for generating images that agents can use. When doing a demonstration and like training for people, everybody was like hitting it really hard. And yeah, like the default kind of thing that I had going on, which was kind of embedding Stable Diffusion XL into a Flask server, didn't handle that very well. Essentially, like even though generating one image would take 5 seconds, when 30 people or 50 people are kind of accessing it at the same time, Apache in front of it isn't, forgetting any of those requests. So it waits for the WSGI server to have a thread to handle the request, and then it passes it on. And then it takes 5, 10, 15 seconds to process that image, and then it sends a response. But by then, the connection is timed out, and it's kind of like done a bunch of unnecessary work. Now, this doesn't particularly help with that particular problem, but it is set up in a way where I can make 8 or 10 worker servers, GPU servers, which I'm going to set up later today, and have them all listening on the RabbitMQ. So that way we can handle up to 10 requests at once, and they'll just be kind of routed round robin, and hopefully that'll be enough to handle the load of 50 people hitting the server all at once. And yeah, it's interesting because this is async, this is not async, and unfortunately we don't want this to be async because doing Stable Diffusion is not an asynchronous thing, right? Like, it's CPU intensive, GPU intensive. So this being a blocking thing is exactly what we want, but when it is doing this, the thread is unable to kind of connect to RabbitMQ and do things. So that caused a connection issue. So what I did just now is generate image into its own thread, and then give it a queue for sending back the result. So like a Go, like in Go, you'd have there's a Go routine, but this is a real thread, right? So it's a thread. Nothing's really happening in parallel. It's mainly, this is just kind of taking up time in native land, and then in Python land, the thread will kind of every second check to see if the thread is done. And if it's not done, we are going to process any data events from the connection so that it can keep that connection alive. And then we check if the thread is alive. If it's still alive, then we wait another second for it to join, process more data events. Then once that happens and it's dead, that means that the thread finished. We acknowledge the that might be a little premature. We might want to get the queue first and then acknowledge, and then we publish to the images the fact that it has finished, and then from the images topic, the server can then it kind of creates a new connection to RabbitMQ for every user, essentially. And yeah, that is just going to look into that for all the different images, and when it finds the image that is the correct one, the one that this current connection or this request asked for, it'll extract that URL and return it to the user. So that should work in theory, and then the only thing that's left to do is to kind of prioritize these things. I think apps, I need to fill in app WSGI. So this is running on Apache, so the Flask server will run on Apache. The workers will run in their own services, like this, but they need to have this environment variable set up. And similarly, the server also needs to get parameterized to which RabbitMQ it will be connecting to. Yeah, and then once that is done, yeah, deploy like eight servers or so. I think that could be enough for like a classroom of 50 people. And if it's not enough, I just do more. Should be totally fine. And we are currently testing this curl. So we're doing a curl to create an image running on my laptop, so it's super slow, but it gave us a chance to check that we're doing the RabbitMQ connection things correctly. So if this completes without any errors, then the whole threading stuff works and should be ready for some ship it squirreling action. And 1 minute left. But we still have to do the refiner, so I'm gonna wait for that. Man, yeah, Stack Overflow is a good resource for stuff. I'm not sure if ChatGPT would have given me the right answer, but because I'm a geezer, boomer, instead of asking ChatGPT for the answers to everything, I like to Google things. Okay, that is good. That. This is nice. I gotta look in more into AIO and PyTorch. That's gonna be a little interesting. I still got one message in there. 2 minutes to refine. So I guess while we're waiting, we can kind of look at that apple. Yes. If I had the money to buy one of these, we'd already be done. Starts at 4,000. Yeah. And I'm not doing 48 gigs of memory. Like, I feel like if I'm going to upgrade, it has to be an upgrade in every single spec. My current machine has 32 gigs of RAM, so technically 48 is an upgrade. But as you can kind of see, we kind of start to run out. So probably want 64. I currently have 2 terabytes of storage, which is getting a little thin. I'm gonna see if I can go. Yeah, what am I dealing with? 200 gigabytes left, right? So it's like, probably about 4 terabytes of storage at least. And that would be $5,200. But I don't live in America. You gotta do this not in freedom units, but in Japanese units. And that's where things are a little crazy. So what would that particular setup, and I'm not doing the black thing. It's like 4,000. Why is there a 6 here, right? And then you go 64 gigs of RAM and 4 terabytes of storage. that's an 8. You know, like, that's not $4,000. That's like $8,000. And $5,500, right? That's a lot of money. And I've spent not that much money on this Intel Mac, I'm pretty sure. Let's see what it imagined for us. That looks like crap. Weird. Is that an MPS bug? I'm guessing it's an MPS bug. But yeah, that doesn't look great. Which is strange. But to know for sure, I think we're going to have to now deploy this on the L4 machines. Okay, but everything seems to work. Nothing is dying. Server is fine. Task was destroyed, but just pending. Okay, server might not be too happy with that. That sucks. I'd expect this to happen, but in general, this is not a problem for the server because each request will be its own thread. So I think that's okay. Yeah, I think it'll be fine. Anyway. So let's do where does it come up with these things? os.environ at the Google project ID. Then there. I want the bucket name. Do it that way. Great. Let me copy that out and put that into the service. Environment. Oops. Google bucket name. It's not that. The imagine storage 1. Project ID, bucket name. This could be interesting to parameterize this. I'm not going to do that right now. CUDA stuff should be fine. Steps and noise fraction. I kind of feel like that should probably be parameterized. We need the rabbit MQ host port. Username and password. So I want these things to fail if they don't exist, right? MQ host, port, username, and password. host port user password. There we go. Okay, cool. And then in here we'll use these. Host RabbitMQ port, MQ username, and RabbitMQ password. Queues I will hard code for now. And that should be it. Okay. So the worker is doing that. Server should have similar things up here. Import OS, please. Don't necessarily need the bucket name, but we need the project ID, host, port. So for here, this connect robust is fancy. That's fine, you can be fancy too. Username, password, to host, colon, to port, slash. I don't like how that's just one column too far, but I don't care that much. What else do we need to parameterize? We don't hard code anything else. I guess in here we don't need the Google project ID, just the RabbitMQ things. Okay. Cool. Does that's going to say that's going to do a key error. Yeah, so that's fine. I want it to key error. It's got to fail if it is not configured correctly. That is the way. Okay, so I think I will now let's make a project on GitHub for this. Server. Have everything I need. So let me get nips directory. Worker server requirements. App WSGI. Images, I'm going to get keep file in there. And the service. Okay. Do a new get ignore that ignores VM. Okay. Status. I also want to ignore that idea. Commit initial version. That makes me again, please. Let's get rid of this. Look at that. Okay. Now we can get remote add origin. Push. Push that there. Okay, so we have this, and I'm going to get it on the server. I don't have a server, so we'll have to create a new one. A little annoying, but yeah, a little annoying. Not terribly annoying. Just a little annoying that I have to make a server. But we'll just do that. We'll do a general purpose, low cost. This one also can be small. Could possibly be micro. It's kind of like worried about the limited CPU shares. It's mostly idle. How much does micro cost per month? $7. $7, yeah. Anyway, I think I'll need a little more disk space. 32 should be fine. And Debian, this one should allow HTTP traffic. I think should be good. Say EU app1. Cool. So now we have that server, and then we'll get it set up for running our WSGI, which I forgot to mention. We need to set up this thing. So let me double check what I had. Okay, so for this, we need to import sys, import site. In sys, we need to insert the app directory so that it imports correctly. We'll be using Python 3.9. Import the app as application. That should be good. Okay, and with that, we should have a WSGI kind of configuration that we can use. I do think I need to change it 755, but we can do that on the server too. Anyway, the server is now up, so we'll grab it. And do things the old school way. Because I don't want to deal with it. Like, I don't want to deal with the Docker. I don't want to deal with Kubernetes. We do have Kubernetes, right, and Docker things all over the place, right? But in this instance, it's just SDXL, right? Like in a Flask server, I don't want to deal with all that stuff. Okay, so for this server, we will need Apache 2. So we'll sudo apt install Apache 2. And because we're using WSGI, let mod Apache 2 WSGI. I think is what it's called. I was wrong. Apt search G2 WSGI, something along those lines. Pretty useful. Apache 2 mod. I forget what it's called. Lib Apache 2. Lib Apache 2 mod WSGI Pi 3. That's what we want. I could totally do this with Ansible. I probably should. Okay, so now WSGI is enabled. I want pip, right? Pips. We'll need to do apt install Python pip 3. Python 3 pip. I do think that is correct. It's got to install the entire world, but that's, like pip can compile things right from C++ and stuff like that. So you need all the build tools, and it's kind of unfortunate. I'd rather my servers not have GCC and stuff like that. But that is what Docker is for, Okay, so now we'll go to var www. Make imagine. Data www data imagine. Change on. It is 1 a.m. Okay. So now imagine this. It is writable by www data, which will be necessary. Now let's copy things over. Easiest way will be with Git. Git archive. Didn't like. I want to do Git archive head. Then we can upload that file. Go back here, upload. Projects, Express AI, expand management server, return GZ. Where did it updated? I don't know. That's fine. Oh. That's weird. Yeah, Google's like super secure in the way it deals with this stuff. But it's also a little weird sometimes. Should be able to upload this jar ball. Yeah, there we go. Transferred. That's what I was waiting for. Okay, so if we do that, not what I wanted at all, but good enough. Let's move the, okay, what do I have here? Move all of these things, that should be good enough, right? So do move everything into var, www, imagine. Okay, cool. Change constant for 5 app.wsgi. And we need to go to Apache 2 sites available. So in there's a 000 default conf, so I'll create a 001 imagine.conf. Sites available. Okay, so for imagine conf, we need to do virtual host listening on port 80. The server name should be imagine.public.cloud express.ai. Timeout of 3 minutes. We have a WSGI daemon process. Group equals www data, so that way that's the user. Processes, threads. Not so sure about that. Processes 2. Let's leave those as defaults. I'm not sure what the defaults are, but we don't need to limit ourselves in this sense. Python home will be var www. Imagine VM, the Python path. It's going to be var www. Imagine, and then var www. Imagine VM lib Python 3.9 site packages. Not sure if this one's necessary because we did specify it somewhere else. Alias slash should go to r www imagine app.wsgi, and that is what will mount our app into slash. We need to have imagine b a WSGI process group and WSGI application group. Then the standard order deny allow, then allow from all. Okay, now we have these images. Actually, if I don't set it, I don't think we'll do anything there. Yeah, pretty sure that's fine. And virtual host declaration. Oh god damn it. Always forget well, not always, but often forget to SUDO my VIs. So let's go back here and then those. Move those things. Wait, those things might still be there. There we go. And with an empty line, that looks okay. Write that. Then do SUDO A2 end site 001 imagine.conf. Before we do that, we need to install the requirements, right? So Python 3 and VM, let's create that. I don't want to create that as root. Which we cannot do. Bash. Everything is on my egonsols anyway, so yeah, we can do it this way. Python 3 m VM, which we cannot create because this is currently owned by www.java. So let's do make change home. So let's do that again. Oh, forgot to install VM. We also need that. We do that, and then we source that VM bin activate and pip install requirements server. -R. Okay, so hopefully that should be everything. That's not everything because we need the environment variables, right? And doing that, I think there was something in here. Let me open that again. Imagine conf. And I think there was a environment directive. Yes, set and yeah, that's what it is. Okay, so in here we'll do set env. It's nice and blue, is what we want. And let's do RabbitMQ host. And that will be .5, and we set env.mq port to whatever it should be. What was it? 5672. Yeah, it should be 5672. Set env RabbitMQ user to guest for now. And Rabbit password should also be guest. No, since that's not accessible from outside, that should be fine. And then we need to change own cursively www.data, this directory. Do that as root. Okay, that looks good. We can get rid of that imagine.tar. Then we enable the site. Site 001 imagine.com. Systemctl reload Apache 2. And there is problems. So let's see what the problems are. Line 7. Did I forget something? There we go. Yeah. Okay, so let's reload. And that failed again. What is it this time? Allow requires 2 admins allow from all. How did I fail allow from? Oh. There we go. Okay, reload. We're good. Okay, and I should be able to access that from HTTP. Cool. Not what we want, but good enough. Let's add a little host thing. So if I map that to the name, which was imagine.public.cloud.express.ai. Okay, cool. So that is not what I want, but I'm pretty sure it's fine. Pretty sure it's fine. Okay, now for the workers. So that is set up. We need. Ooh, can we curl the RabbitMQ? I'm going to change firewall settings. And refused. We're not allowed. Okay, so that's correct, I think. That should be, it's fine. That is working. Okay, so that's good. Let's go to the worker now. Okay, so the worker used to have that. Let's upload Imagine in here. And this I think we're done with, so let's close out of that. That is no good. Let's move that Imagine to the old one. Let's restart. Wish that uploading worked a little bit better. But you can't complain. It's not too bad. Okay, let's upload that. Okay, that is transferred. Let's make dir Imagine old, make dir Imagine RZXEF Imagine.rgz. Okay, so now we have that. Now the main thing is this Imagine service and this worker pi. So I'm going to copy worker pi into var.ww Imagine. And in var.ww Imagine, since I have a virtual env in there, install -r environments worker.txt. That should grab us some new stuff. Okay. Now we need to copy the Imagine service.service into etc systemd system. That's where all the services are. Copy that in there. System Imagine service. Okay, so in this place, we're going to be doing things a little different. Application credentials. That's the next thing I have to do. Rabbit. Okay, and then we want to get finish. Totally forgot we didn't finish that. Okay, so cool. So let's do that. Equals, and then our RabbitMQ IP address. Environment. And let's get the port equal to 5672. We want our user and password. the guest. Okay. Oh wait, why is it all down here? This file isn't like super messed up, is it? It is. Weird. Okay. Don't know when that happened. Okay, so let's get rid of that. Those are... Oh wait, I think I missed something there. Yes, the Google bucket name is important. Working directory was already set. Install. It's just that. It's weird. Why did this get like messed up? That is weird, but doesn't matter. Easy enough to fix. Okay, so I think that should work. Let's give it a try. There you go. Systemctl reload. What was it again? I have to look it up. It's been a while. Systemd reload. Daemon reload. Yeah, that's what it is. So we want to tell systemd to reload its daemons. Okay, then sudo systemctl status imagine service. Okay, so let's start it. Start imagine service. And also enable imagine service. We have a journal. Okay, start job has finished successfully. Look at the daemon log. Failed with result. No Google project ID. I see. So let's take start and make it a stop. VI main service. And this is not Cloud Project, but Google Project ID. Okay, now let's also do credentials. So I'm not mistaken, we can go in here, as we don't need to show the different credentials in here. And we can do service accounts, create a service account. So we're going to imagine service. ID should be the same. This thing should have essentially storage access. So this can create objects that transfer, create transfer jobs, and multi-part uploads. That's what we want. Okay, service account, service role, we don't need that. Cool. So now we just download that, open that up, go to keys, and we can create a new key in JSON format. And now if we go here, upload that file. So let's move that to agent. What was the thing we called it? We called it agent platform dev.json. So just move agent platform dev whatever to our www imagine agent platform dev.json. Now we should be able to start the worker. Load. I think we can follow this. Okay, let's stop that. We are now storage bucket lists denied on resource. Great. Okay, so let's grant access. Let's edit details, permissions, roles. Storage. I have a feeling this is not what we want. This thing. No, that's not what we want either. Where's it? Hidden service. Here we go. Add another role. Storage. Search is kind of weird, so I'll not use it. So cloud storage. Needs access to listing, and we need to give it access to listing buckets. Why do I have to start everything with cloud? Okay, cloud storage. Let's see if folder admin is good enough. Start. Controls. Okay, never mind. Stop that. Okay, let's go back here. We are at that's fortunate. If that's the case, what's the point, you know? Cloud S cloud storage admin save. Okay, let's start. Look at the logs. It seems to be running. Okay, something's wrong. CUDA out of memory here. Okay, makes sense. So this is running the old Flask thing, so we got to do a to dis site. Um, 001 imagine.com. TL reload Apache 2. Okay. Now if I do NVIDIA SMI, things are empty. That's good. Now, if I status, we are running. And if I look at logs, disable SSH onto this machine. Started imagining. Expected keyword args username and guest. Should probably have looked at that first before blindly accepting whatever it is this thing said. Let's see, Pika, blocking connection parameters. There's a credentials, right? Let's look at Pika credentials. Using the password aren't there. Credentials? Small credentials. Okay. So for the worker, weird that worked locally. Connection monitors user password. See, well, peek up plane credentials like that. Yeah, it's so weird that worked locally. Or I guess maybe we didn't check. Yeah, we didn't check. So it should be credentials is like that, and then we have credentials equals credentials. Okay, since I don't want to deal with that stuff right now, do then tc var www imagine and I'll just edit worker directly. Put these things here. Okay. Start imagine service and look at our log, which was journal CTL. Says refused for playing. Okay. So let's stop that. Now let's go to the it's kind of weird. I wonder how are these SSH coming in? I gotta check that. Yeah, let's look at the RabbitMQ instance. How complicated is it to reschedule a failed job with Rabbit? It's not complicated at all. There's you can have rules about dead letters and things like that, and I think they're all things that you can set in the management API. Let me check out how to do the authentication stuff. If I can find out how it's supposed to be done in Debian. Okay, can I do these guys are like, oh yeah, let's install RabbitMQ with like compiling it from scratch. Let's do apt search. Let's see, was there admin stuff? We just got the server, and I think we need the RabbitMQ tools. I want AMQP tools. Okay, so yeah, we can really do that. So let's do help subcommands. I think we can do like list users or something like that. Yeah, list RabbitMQ admin, list users. And what was this? We want a username. I see, that could be a problem. But pretty good, I guess. Why is everybody installing RabbitMQ? Let's first see the status. System CTL status RabbitMQ server. It is running. Let me make sure it is enabled. Okay. Status is good. RabbitMQ CTL. Okay, there we go. Yeah, wait, that's why. So let's add some users. And we add a admin. RabbitMQ CTL set user tags, admin as an administrator. Then RabbitMQ plugins enable. Okay, let me see if I can get that working here. Do a daemon reload real quick, and then we can start it. Okay. Stop. What is it this time? Okay, so it doesn't like plain, so I gotta figure out how to enable plain or do things a different way. Should be fine because it's a private network, so like it's not a problem. Oh, okay. I see. Guests can only connect via local host or something like that. That could be something because this is probably a little bit old. Weird. RabbitMQ admin. Okay, there's definitely an admin. If I get the password wrong, access refused. Okay. Let's look at the broker log file. Cat var log RabbitMQ. RabbitMQ server error log. Nope, nothing there. RabbitMQ server log. We find the RabbitMQ rabbit at RabbitMQ1.log. Okay, you can kind of see there's some stuff here. Invalid credentials for admin. Interesting. Let me double check that I got those right. Should be right. Let me create another user. Maybe that's a better idea. Let's create an imagine user. Okay, and we will create an admin user, set user tags. And set permissions to the vhost or imagine. Start, reload, start, journal. Login was refused. Okay, so I think this is, so username and password is fine. So it must be some other thing. Let's see, where was I looking at stuff? I was looking at stuff. Go, RabbitMQ, got the permissions. What could be the problem, or I should look at, simple stuff. So if we go to etc RabbitMQ, let's look at the RabbitMQ env.conf. Okay, should bind to all interfaces and use port 5672. Let's see, RabbitMQ configure authentication. Credentials and passwords, that sounds pretty good. Password hashing module, credential validation. Passwordless users, interesting. I'd like to know if there's something I can do, like a curl or something like that. That would be cool. Access control guide. Okay, so what I'm thinking is that the Debian default, kind of like RabbitMQ, is configured to not allow plain text connections. So that password user list users, delete users, permissions, which I did. Your permissions we don't need. Okay, good stuff. Invoking, combining backends. Okay, so it's possible to use multiple backends for auth backends. The default is internal. You can configure to use OAuth or LDAP. Very cool. Plain. Okay. It says enabled by default, but that could be a Debianism. Okay, so we need to go to the configuration file. See the auth mechanisms. Is there a way to use RabbitMQ CLI for auth mechanism looking? Look at the man page. List connections. Mechanism. So if there's someone connected, we can see that connection. So if we do, this was for the admin, right? So RabbitMQ list connections. Underscores. Yeah, we can kind of see it that way. Is there a config policy set parameter list parameters? Not a lot. List permissions, access control, can list users. We have an imagine user who's an administrator for now. And let me restart. I'm not sure. Looks like Claude now has a 200,000 token context window. Anthropic isn't giving up. It's kind of good to see. Okay, let's try this again just in case. And stop that. Failed. See the broker log file. Guest can only connect via localhost. Yeah. Why are we connecting with guest? Worker.py, RabbitMQ username password, and then we set the credentials. Ah, yeah, that would do it. That would totally do it. If you read RabbitMQ password. That would totally do it. Okay, so let's start that way. Scale that. Journal, see if everything starts or if we fail with something else. Okay, access granted. Should not be able to connect. Okay, looks like we're up and running. I think we're up and running. Yes, it does look like we're up and running. So if we go here and change that from this to first, we need to update my Cloudflare. So let me do that real quick. Might need my keys. Okay, so the app IP. this. So let me do some DNS work real quick here. You should be able to see less things coming there for successful. Get this new IP. Save it. Okay, cool. And if we do public imagine, or no, I got it backwards. Imagine.public.loud express.ai. Got an error. Internal server error. Which I think is good. Let's see what that error is. I really don't like that people can SSH into these servers. Kind of feel like, yeah, if Google's like giving you servers without keys in the first place, why even let them kind of be accessible from SSH by default? Anyway, let me check if there's any more, like no more chats. So let's do the last part here. So let's look at the Apache error log. Var log Apache 2 error log. Key error rabbit MQ host. See patch 2 sites enabled. Comp rabbit Q host. These things are not getting in there. Let's restart that. Let's tail the error log. Okay, and go here, try that. Fail to exec. Key error rabbit MQ host. That is annoying. Why would set M not work? Did I mess that up? I don't think so. The daemon process might not get those. Just double check. I set M. Okay, lots of information and updates. Sure. Set emp direction has no effect on OS environment. I see. because there's a request environment. Not very useful. Okay, we can do something else. You don't have to do things that way. I don't think. We can set the OS environment inside. Let's look at the configuration guidelines. Okay. We can configure those things. Yes, let's see if there's environment. If it is necessary, pass configuration through use setem. Okay. So they're added to the WSGI environment. It's passed upon each request. Is that helpful for us? Okay, so we've got to do something else there. Let's take these environment variables. Don't know how this is supposed to work. The main one I want is this, whatever. Okay, so we can go to rwww.imagine. Oops, I'm in Japanese mode. Okay. I'm wondering if setting them here will do that. I don't think so. Give that a try, I guess. Really don't think so. I don't. Like, really not sure if this will work. I don't think it will, but it might. If it works, then well, good enough. Can we do a full restart Apache and do this again? Okay. Tail the error log. Carbon key port. Okay, so that does work. Cool. Now we just got to do the rest, draw the rest of the owl, as they say. Okay, so let's copy that 4 times. Make this be port. User. Server. User and password. So port will be, I guess it should be a string that's from there. 5672. User is imagine. Then let's set the password really quickly. Okay. And then restart Apache again. Tail that log. Do that. Didn't immediately fail, so that's good. Now this server is running. This is the GPU server. You can watch NVIDIA SNI to see what's going on there. Oh, it looks like we got an image that looks like crap. Okay. That's no good. But it does work. Looks like crap though. Why does it look like crap? Let's look into the worker here. Yeah, 40 steps. Old server Pi also had 40 steps. So that worker here. FP16, save tensors. Should be using CUDA this time. We are. 10 steps is 40. That's good. We aren't not doing it. A little weird. Let's do something different, like illustration of a lion loading a space suit floating in space above the Earth. That got the image. Looks like the steps aren't enough. Or something's up. Something weird is up. So weird. Let's comb through the old code, I guess. This should be the old code. It's pretty much the same. Base liner. Let's go through here, see if I missed something up here. I don't think so. Float 16, got the using safe tensors. basing it. Got stability and XMP and XL Refiner 1.0. I think 40 steps, 0 to noise fraction. So weird, that is what it is. Stability AI, SDXL. Essentially, if you look in here, like I'm expecting these kind of images, right? Accelerate safe tensors. Base. Okay, so the refiner, like that, should be everything. Number of steps should be 40. Type latent, like either like I have some sort of weird typo that is being ignored, or like the order matters. That would suck. No, the order shouldn't matter. It's impossible to matter. Refuse to believe that it would matter. Let me get rid of those steps real quick. Essentially, go to the worker. We delete these two. We start imagine service. Okay. And redo this. Now we're not like limiting to 40. Whatever the default is what it should be using. But it's weird. Really weird. Okay, that works better. Okay, so I think that's good. We're going to ship that. So ship it. Cool. So now that that's working, I want to scale this out, and then I'm going to be done with the stream for today. So to do that, I'm going to turn off XAI EUGPU1. Okay, operations, stuff. Okay, so just to kind of document how this works. So, I'm doing everything by hand. I kind of mentioned before how I didn't want to deal with Kubernetes and things like that. Now, everything I'm doing here should be done by Kubernetes or Ansible or something like that. But when you're doing it the first time, and there's things you're not sure about or haven't tried yet, doing things the manual way is the fastest way to debug things, right? Like everything makes sense. You have access to the server and Vim and all the things. And when you're dealing with Kubernetes or like stripped down images or Docker or things like that, none of those things work. Now that I have everything that's in a working state, wrapping it in a Docker thing will be much easier. I'm not going to do that. I'm going to still do things the old-fashioned way, but that's how it is. Okay, so I'm going to create a machine image. I'll call it Imagine V2. Queue-based worker, Imagine. Okay, just going to keep it in there. Google's keys should be fine. Let's create that image and see if this works. So I tried making an image of it while it was running. Doesn't work. Definitely doesn't work. Not sure why, but it definitely didn't work. So I'm going to try and create an image of it shut down and then start two machines and see if we can do it that way. I just realized the music might be a little loud. Very sorry about that. Usually I turn it down. And I kind of forgot to. So it's turned down now as we are near the end of the stream. But anyway. So that was a lot more debugging than I was expecting. Something about this is very weird to me. It could be just that we're using a newer version of it. Maybe they changed the name. Anyway, so let me fix that. So service and get this into. Okay, so this is Google Project ID, right? Application credentials. Okay, bucket name, host, port, user, password. I think I've used MQ without these. There we go. And that want by, and that's all we need. Okay, so I'll fix that. Then the things in server are the same, right? So if we take these, put them in the app WSGI here. We need these things. Okay, so let's commit that. Okay, push that up. Do we have an image? We don't have an image yet. So, yeah. You gotta wait a little bit. Creating an image can take a while, especially when you have a really big disk like I have here. And essentially, it has all these like models in it, a lot of models in it. So that's why it's taking so long. Let me delete that tarf. Yeah. These things. These things, I think those are good. It's okay. These are okay. Clean up that. The callback has 2. This has 2. And the only errors are this weird white space thing. Yeah, don't care about that. And this error is no line end of file. So I'm going to keep it as properties. You never know, you might need it. That's fine. Okay, and then push that. Okay. So anyway, I don't think it's worth waiting, 30 minutes for this image to come up. Essentially what I'm going to do is, once this image is here, you can create instance from that image, and it should work, because we saw it. We created multiple queues on this thing, so we're just creating a bunch of single GPU machines that work on the queue. It should work fine. I can make one machine with multiple GPUs as well. I just make more than one Imagine service, like Imagine Service 1, Imagine Service 2, Imagine Service 3. But setting that up is a little bit more difficult. But not so much so. It's like all you really need to do to have it kind of run on multiple GPUs is to specify the NVIDIA visible devices. So depending on which worker it is, it'll set that visible device. And when it starts, it'll be running on GPU 0 or GPU 1. So it doesn't have to be separate servers per se. But that is, so I am thinking of that as a plan B. So just in case this image doesn't work, which it might not, I still can like update my servers and kind of get them working that way. But anyway, so that's going to take a while. And it is almost 3 a.m., so I think I'm going to leave it here. Thanks everyone for coming along and kind of seeing how this works, and hope, if you're interested in it, I hope you learned something. And next week we'll probably be back again Maybe doing some more things with Rust, doing some more things with the vector engine maybe. Had some plans of maybe doing that today, but we didn't have the setups kind of set up correctly. So just wanted to do this thing which I needed to do, and we did it. So yeah, with that, I'll see everyone next week. Cheers.